So hello guys and welcome to the third video of the series ROS Basics. So in last video we discussed about launch files and something else such as parameter servers, launch files, and about nodes. Yeah. And so in this video and the next video we'll be discussing ROS topics. So in this video you'll get to know about ROS topics and about publisher and topic messages. So let me first explain you what a ROS topic is and what a publisher is. So publisher is something that publishes a message to a topic, and in the next video we'll be covering about subscribers. So subscriber is something that subscribes or gets something, and this something is a message, ROS message from a topic. So publisher publishes a message to a topic, and subscriber subscribes to a topic to get a message. Yeah. So in this video we'll write a publisher example and we'll create a topic. So topic is over. So topic is basically a communication channel. So it's an analogous to pipe. So it's basically used to share information. So a node can subscribe to a topic, a node can publish to a topic. So topic is basically the middleman in the message exchange. So in this we'll just directly dive into the publisher code. So for example, this code over here, you need to run it. So first let me show you that whether you just need to see whether there is a topic named counter. Yeah, so you need to send topic with a counter is this one. Yeah, no topic named counter. So you just need to go in here and press this play button. So this code is run, but nothing has happened over here, as you can see. So but we have actually created a topic named counter, and we have initialized a node named topic publisher. As you can see, I'll type in ROS topic list, and there is the topic counter. Yeah, so topic is, as I said, like a pipe, and nodes use topics to publish information for the nodes so they can communicate. Yeah, so I'll also tell you a very useful command over here. For example, if you need to filter out the results, here ROS topic list. So there are, as you can see, there are lots of topics going on, and as you advance in ROS, there'll be a lot of topics that you have to handle. So for example, I need to filter out the topics that have the word mobile base in them. So I'll just type in this / grep head of ROS topic list, grep, and the name of the keyword basically that I want to filter out. Yeah, so as you can see, there are two topics with this keyword mobile base in it. So as we created a topic named counter, so let me type in ROS topic list grep / counter. Yeah, so there's one topic named counter, and if I need to see information about this topic, I need to type in ROS topic info counter. Yeah, so there we go. As you can see, the output has the answer to this command has basically three major terms: a type, a publisher, and a subscriber. As I explained, publisher is something that publishes to a topic. In this case, the publisher is topic publisher. I'll just explain you in few minutes why this is named topic publisher, or you can name it something else as well. And this type is the type of the message that gets published to this topic. In this case it's int32. These standard messages you'll get to know about in a minute. And subscribes, currently this topic counter has no subscribers, so so before proceeding further, let's just see whether something has been published to a topic or not. Actually, in the code, an integer gets published to a topic that increases indefinitely. So I'll type in ROS topic echo, and the name of the topic that I need to echo, in this case counter. So as you can see, yeah, so this is the data that is being published. So why this is termed data over here and why is this incrementing, you'll just get to know in a minute. So yeah, now I'll explain you the code, and the code is over here. Yeah, so there we go. So this was the code. Firstly we type in import rospy, so that's basically to import the Python library for ROS named rospy, and then we imported this int32 message from the centered messages packages. So what happens basically is that there is a folder, the standard messages, and in that folder there is a folder directory named message msg, in which all the message types are defined, and then this is the int32. So basically in the folder you'll when you create a message type, you'll type in int32.message msg.msg. so this has already been done. This comes in with the standard messages package, standard messages package that comes out in ROS by default. So in the next line we initialize a node named topic publisher. That's what I was talking about. So this node topic publisher over here, that was the so that was the name that came in here. So if you change, so basically this, the name of the node that publishes to the topic counter is topic publisher. So if you'll type in some other name over here, that will reflect over in the ROS topic info counter in the publisher section. Yeah, so in the next line we created a publisher object. So we created a publisher object named pub that will publish a message to this topic. So I need to type in two arguments basically. So the first one is the name of the topic. So again you type in the name over here, that will become a topic. If I type in, for example, abc, then over here instead of counter it will be abc. So this is basically the topic is defined here, and then I need to type in the message, the type of the message. In this case it's int32. Then I set a publish rate of 2 hertz, and then I created a variable of type int32. And then as you can see over here, so int32 has only one attribute, and that is data, and that was being published over here. So that I initialized to 0. Then I started a loop so that this process goes on until someone stops the program execution by pressing control plus C or something else. Then I publish the message, I publish the variable count of the type int32 by a command. This is the object that I created above by a command pub.publish. And then the next step, I incremented the attribute data of type int32 of variable count by +1, and then I set it to sleep. So it's basically the state.sleep basically make sure that the publish rate remains at 2 hertz. So again a very important thing to note about in here, I am changing the attribute data of this type int32. So to know more about messages, so let's go forward a little bit. So as I have been saying messages a lot of times in this video, so I'll just explain you what a message is. So message is basically thing that has the information in it. So topics handle information from messages, and there are many different types of messages. In the case of the code we executed before, the message type was, let me show you in the code. So the message type was standard messages int32. std messages is the standard message package, and int32 is the type of the message. You can always define your own message, but it's always recommended to use the standard the message types that already comes with the standard message folder, or you can use already defined your default messages. So the messages are basically defined in a .msg file. I'll just show you here. ROS std underscore msgs. So there we go. There'll be a, yeah, there's a folder message. So basically over here there's a code. Yeah, so from std messages package, and there's a folder msg dot msg, we import a message. We import a message that is of the type int32.msg. so int32.msg, not this, yeah, there it is. So now if I need to know more about this message, let me type in ROS message show. std, sorry, yeah, ROS message show. So my message was standard msg, sorry, msgs. Let me change. So my message was show std message type enter, sorry again, int32. Yeah, so as you can see over here, it has only one attribute named data of the type int32. The name of the message is capital int332.msg, as I showed you here. Yeah, and in this file there's simply a variable data of the type int32. So yeah, so by now we've already covered what a topic is, what a publisher is, and what a ROS message is, and I've also shown you an example of a publisher and an example of a type, and I explained you the structure of a ROS message. So it's basically the variables and the types defined in a .msg file. So now there's a short exercise for you. I'll just explain in the exercise. So when the exercise, we need to create in our own publisher and make the robot move. So again, we are using Kabuki robot in this video as well. So basically what the exercise is that you have to create in a package. I explained you in the last video how to create a package and how to create a launch file. So you need to create in a package with a launch file that launches this code, simple topic publisher.py. You will have to edit the simple topic publisher.py and .py and modify the code you used to publish data to the CMD velocity topic. And what a CMD velocity topic is, I'll just show you. ROS topic list. So as you can see over here, that's a CMD velocity topic, and ROS topic info CMD velocity. Yeah, so there's an info, there's no publisher to this topic. So basically you'll have to, currently there are no publisher to this topic, you'll need to publish some information to this topic. And there's a subscriber Gazebo is this modeling software. You don't worry about this. You'll have to create a publisher that publishes to this topic CMD velocity, and there's a type associated with this. The type of the message geometry messages dot list. Let me show you the structure of this message dot twist. Yeah, so there we go. There are basically two attributes, main attributes, a linear one and an angular one. And so this is the type. There's a three vectors, there's a x, y and z. So these are all of the type float 64. So what you need to do is that you need to modify the code you use over here, this code, to publish a message, to publish data to this CMD velocity topic. You know how to manipulate the data within a message and how to publish a message to a topic. So CMD velocity is basically the topic used to move the robot. So we've already done this, we know the information about CMD velocity topic. And in order to fill the twist message, we need to create an instance of the message. So I have already explained this as well. So in this case you'll make the variable of the twist type. There you go, because the type of the message was geometry messages slash twist. And in order to know the structure, we already done this ROS message show command. And again, one very important thing to know is that the robot can only move linearly in the x-axis or rotationally in the angular z-axis. So there are only two variables that you need to modify, and so try it by yourself. And so now I'll just show you solution. So I'll request you to try it by yourself, and if you can do it, then you can cross check your answer, and if you can't do it, then you can refer to this upcoming explanation of the code that I just wrote. Firstly, I wrote a node simple topic publisher. This all has been explained already. So from the geometry messages dot message, I imported the message twist dot msg. Then I initialized the node named simple topic publisher, and then I did all this already has been explained. Then I basically modified the data within the message type twist, and then I simply published it to the cmd velocity topic. Then you need to write in a launch file. I've already done so. So there we go. So I'll just show you the output of my code and launch file. So I need to type in ROS launch. The package I've named it exercise2_1, and the name of the launch is launch.launch. So as you'll see over here, the robot will start moving. As you can see over here, again it's moving in circular direction because I have simply provided the velocity in the linear x as 0.5 and angular velocity about z as 0.5 as well. So this was a solution of the exercise. For more clearly, just see here the solution of this. So this is the solution for your reference, and launch file, I know you can write it by yourself. So this is for your reference, the code for the launch file. So that was all for this video. In the next video we'll be discussing about subscribers, and we'll get to know more about topics. So thanks a lot for this video. Hope to see you soon in the next video. Thank you.